In this example, we want to look at a set of vectors, determine if they are linearly independent, and then if not, find a basis for the span of those vectors. So the way we go about this problem is to put these into a matrix as the columns, and then row reduce the matrix, and that will tell us, A, if they are independent, and if not, which vectors we need in order to get a basis for the span of these vectors. So let's start by writing this into a matrix. So since we already see a 1 in the top left corner, we can use that 1 to get rid of the -1, 2, and 3 beneath it. So the first row will stay the same. We want to add one copy of the first row to the second row, which gives us all zeros in that row. We want to subtract 2 copies of the first row from the third row. It's a 0 in that spot. -1 minus 2 times 2 is -5. 3 minus 2 times 1 is 1. -2 is 0 is -2. And for the last, I want to subtract 3 copies of row 1 from it to put a 0 in the first spot. 1 minus 3 times 2 is -5. 4 minus 3 times is 1, and then that's also -2 again. Now to go further, I need to be able to put a 1 in this first slot here, which I can't do, so I'm going to swap the bottom row with it. And I can see that by subtracting row 3 from row 2, they're the same row, so that's going to go to zeros, leaving me with the following matrix. So from this I can see that I do have a couple 0 rows here, or in particular I have non-pivot columns here and here, which means that these vectors are linearly dependent. And I can take the first 2 columns as a basis for the set because these first 2 columns are my pivot entries here. So I can use these first 2 columns, which are 1 minus 1, 2, 3, and 2 minus 2 minus 1, 1, as a basis for the span of these vectors. Which means that we know that this is therefore a dimension 2 subspace. It's subspace that span and it has a basis of 2 vectors, therefore it's a dimension 2 subspace. So that's the idea of using row reduction to talk about linear independence of vectors, as well as finding a basis for a span of vectors if they happen to be linearly dependent.